We talk a lot about AI creating content, and it's really easy to lump it all together text, images, video. But the thing is, they're not all the same, not even close. The way an AI generates a picture is fundamentally different from how it writes a sentence. So today, we're going to look inside the machine and really understand the specific pipelines that create the images and videos we're all seeing.
All right, so here's the game plan. First, we'll highlight the huge differences from text generation. Then, we'll walk through the actual multi-stage process. After that, we'll get to the real heart of how it works. Then, we'll tackle why the results can feel so intelligent. And finally, we'll land on why getting this mechanical process right is just so incredibly important.
Okay, so right off the bat, we've got to draw a line in the sand. There's how we think these systems work, and then there's how they really work. It's super easy to imagine an AI painting a picture like a person would, but the reality, it's much more of an engineering problem than an artistic one. And this slide, this gets right to the core of it. On one side, you've got text generation. It's often a pretty direct process, predicting the next word in a sequence. But for images and video, it's a whole different ballgame. We're talking about a complex, multi-stage pipeline that isn't playing with pixels on a canvas. It's transforming abstract mathematical data. Look, it's totally natural to think of the AI as seeing our prompt or understanding what we want. These mental shortcuts are like scaffolding or training wheels. They're great for getting started. But, and this is a big but, if you're doing any kind of serious work, especially where you need to assess risk, you have to take the training wheels off. You have to understand the real machinery underneath. So, okay. Let's ditch those simple analogies for a minute. What does the actual process look like? Let's really unpack the formal mechanics of how this stuff gets made. And this is absolutely crucial to get. An AI-generated image isn't the result of a sudden flash of inspiration. There's no visual reasoning happening. It's the end product of a very carefully engineered, step-by-step procedure.
And here is that procedure. First up is conditioning. This is where your prompt, your words, gets translated into a purely mathematical concept. Then comes the refinement phase. The system literally starts with a field of digital static, just random noise, and then slowly, step by step, it shapes that noise to match the math from your prompt. And finally, before you ever see it, it goes through a filtering stage for safety. It truly is a factory assembly line, not an artist's studio.
And then there's video, which just adds a whole other layer of complexity. Because now it's not enough for just one image to look good. Every single frame has to logically connect to the one that came before it. Maintaining that consistency over time is a massive challenge, and that's exactly why generating video is so much harder and way more expensive, computationally speaking.
Okay, so let's go back to that iterative refinement stage we just talked about. What is actually happening there? This is really the core of it, and understanding this helps demystify the whole thing.
This right here is probably the single most important concept to grasp. The model is not choosing pixels. It's not an artist picking out colors. It is shaping probabilities. Think of it like this. It's not thinking, I need a blue sky. Instead, it's adjusting a huge set of numbers to increase the statistical chance that the final pattern of pixels matches the mathematical representation of a blue sky. It's just nudging random noise into a highly probable pattern. Right. So once you get that it's all just a mechanical statistical process, you can start to see the outputs in a totally new light, because the final image or video can often feel much, much more intelligent than the process that actually created it. And let's be real, the results can be absolutely stunning, right? You get this image that's visually gorgeous, it's coherent, it makes perfect sense, and our brains are just hardwired to see that and assume there was some kind of thinking, intentional, creative mind behind it all. But that impression, it's completely misleading. We have to keep reminding ourselves that just because the output looks and feels intelligent, it doesn't mean the system has any real understanding or intent. It's an incredible pattern matcher, not a thinker. So this really breaks it down into two different buckets. You have perceptual impact on one side. That's what we experience, that visually persuasive, coherent thing that looks amazing. The pipeline is built from the ground up to amplify that. But then you have reasoning, the actual intelligence, the understanding, the intent. And that's just not part of the process. The system is an amplifier for perception, not a generator of reason. All right, so let's bring this all home. Why does this distinction matter so much? Why is it so critical to use this formal mechanical model instead of just going with our gut intuition? Well, because when the stakes are high in regulated industries, during audits, for really important decisions, you absolutely cannot afford to be vague. Using metaphors like the AI brain or talking about the model as a mind is actively misleading, and In these contexts, prohibited. To properly assess risk, your language and your diagrams have to reflect the mechanical reality, not the cool illusion it creates. So, this all boils down to a few key takeaways for anyone using these tools professionally. You have to interpret every media output with caution. You have to recognize that the way an image model fails by, say, creating a person with 7 fingers is totally different from how a text model fails. For any serious risk assessment, you must use the formal pipeline model. And you have to avoid those easy but wrong model as mind analogies in any formal setting. And that really leaves us with a final, pretty critical question to think about. If the output feels so intelligent, but we know the process behind it is purely mechanical, how does that change how we validate it? How does it change how we trust it? This gap, it forces us to be more rigorous. It means we can't just rely on our gut feeling. We have to lean on a formal understanding of the process, especially when we're using these incredibly powerful assistive tools.